Welcome, everybody, to session 1 or session 2, depending on how you're counting, of Hack Summer 21. My name is Taggart, and tonight we're going to be taking a look at basic Linux commands and the Linux file system. Not a whole lot of prelude, really, so let's just get right down to it. If this is your first time here, though, you're very welcome. I will recommend that if you missed the first session, that you check it out either here on Twitch or, since we still have time at this point, or you can check out all old videos on YouTube. All right, with that, let's get right into the evening's material. It might not be evening for you. All right, so we're talking about the Linux command line. And also, we're going to be talking a little bit about navigating the file system. That's going to be our first entry into the Linux command line. Now, this course, remember, is intended for absolute beginners, people who maybe haven't ever worked with Linux at the command line level before. So that's okay. Before we jump in and we get our lab VM started that we set up last time, I want to make a couple of points. The first is, do not be afraid. It's okay to feel lost. It's okay to be confused. What's not okay, especially during this live stream, is to remain silent if you're feeling that way. If I'm going too fast, please let me know in the chat. I'll slow down. I'll go over stuff again. I want you to ask questions so that you don't feel lost and that you feel like you're in a place where you can learn. Absolutely nobody here is going to say anything disparaging about anything, any kind of question. This is 100% a safe learning space for all who want to learn. So I want to make sure that you understand that before we get going. What we're about to look at is something called the shell, or a shell. And you can think of a shell as just a set of interfaces and commands that we use to interact with the Linux operating system. There's more than one kind of shell. We're going to be using one called bash, which we'll talk about more a little bit later. But that's really kind of where we're getting started. Before we go any further, then, let's turn on the lab VM and make sure that we have everything up and running and that we know how to connect it to the lab VM the way that we set up last time. So here I have my VirtualBox window ready to go. I have this set up here. Now, I'm also going to try something just to see if I can do it. See if I can use my magnifier. Oh, yeah. Okay, so what we're looking at here is our Hack Summer 21 virtual machine, and it should be configured pretty much the same way. We gave it 4 gigabytes of RAM, and that's pretty much all that we really need to know about it. But what we're going to do is power it on. So to do that, we're going to right-click and choose Start and Normal Start, or you can just click on the big Start button right here. Now, this is going to start it in kind of a detached mode, meaning that you're going to see a window of the computer starting up as though you were in front of it. You can also start it in headless mode, meaning that the virtual machine turns on, but you're not going to see any sort of display. So I'm going to do Normal Start. And we should see, yep, a boot up process here. Now, as a reminder, as this thing is starting up, let's take a look at the networking configuration that we set up for this last time. In port forwarding, and I'll zoom in on this so that we can see it a little bit better, we set up a port forwarding, and we can review what ports are, and we will talk a little bit more about this, but we set up a port forward of port, which is like a network channel, of 9999 from the host, which is the computer where VirtualBox is installed, to the guest port of 22. And that is for secure shell. Basically, there's that word shell again. Basically, what we're going to do is connect from our local computer directly into the virtual machine, because doing so through the terminal that we have on our host computer is going to give us a much better interface. So that's the plan. All right. Machine is booted up, And hopefully you remember the username that you set up last time for your machine. But instead of logging in on this interface right here, I'm going to bring up the terminal. Now, if you are on Mac OS, you can use your terminal app to do this. If you're on Windows, you can use either a PowerShell window or Windows Terminal in PowerShell if you have Windows Terminal installed. So mine looks like this. Yours might look a little bit different. That's okay too. And I'll zoom this in a little bit more just so it's easy to read. And what we're going to do is we're going to write this command exactly as you see it here. So SSH is the secure shell command, and we give it the following options. We give it the username @ and then localhost because we're connecting back to our local computer, right? Localhost is an alias for your own machine's network interface. And we give it the extra option of -p and then 9999. Before we go any further, I want to call out that even here, even this command follows the syntax that we're going to see a lot of moving forward. So what are the things we see? We see the command here, we see some options, or we see kind of a target, and then we see some extra options here. And that exactly follows the model of commands being like sentences, right? We have the verb where it's the command, and then we have the object, in this case, the target that we're connecting to. The command is SSH. And then we'll see some option flags. They'll either look like a single dash with a letter or 2 dashes with a word indicating what the option is. And then after that option flag, whatever the value of the option is. And that's exactly what we're looking at here, right? Here's our verb, SSH. Here's our object, right? This is the thing that we're SSHing to. Hey, little D, you're not too late. We're just getting started. We're just about to SSH into our VM. And after our target, we have the option flag of -p, which itself takes some details, like what is the port that we're trying to connect to, 9999. So we have all that set up. I just wanted to call out that this, even here, before we even get into the Linux command line, follows that same syntax that we're going to be seeing so much of. All right, so let's go ahead and press enter and see what happens. If it's your first time connecting to it, you're going to get a message saying, are you sure you want to trust this host? And you're going to type YES to accept that. You have to type all of that, YES, to accept it. Because I've previously connected to this machine, it just prompts me for my password. Once I enter the password, I'm not going to see any asterisks or anything to indicate that I'm typing, but of course I'm typing in, and I'll see it. I'll press enter, and hopefully it'll authenticate. And once I do so, you can see that my command prompt has changed. I'm no longer looking at a PowerShell prompt. I'm looking at a Linux prompt. The Flet, good to see you. Just realizing that I left the music off, so we'll turn that back up just a little bit so we have something underneath. There we go. All right. So we're in here in the Linux command prompt, and if this is your first time, congratulations. You're officially a hacker. But we have a lot that we can do right from here, but we don't necessarily know what that is yet, right? We have to learn something about it. And real quick, just gonna get up my notes so that I don't miss anything. There are a couple of specific commands that I need to make sure that I cover, and I do not want to miss them because I was getting too into something else. Awesome. Okay. So, first thing we're going to do is find out a little bit about where we are. Remember that this command prompt is waiting for your input, but it's in a lot of ways kind of like looking at a text version of the file browser in Windows, right? Explorer or Finder in Mac OS. You're inside the file system. There are files and folders waiting for you to discover. And so the first thing we're going to do is get an idea of where we are. Where are we on this system? To find that out, we have some idea. We're in our home folder, but we don't know what that is yet. So the first command that I want to teach you is pwd. And if the text is too small, shout that out. I will zoom it in. pwd is short for print working directory, and it's one of the first things that I do whenever I'm in a new system. Go ahead and press enter after you type in pwd. And you'll see something like this. You'll see, in fact, let me clear the screen. If you ever want to clear the screen, you can either type clear and press enter, that's another command, or Control L and get that shell all the way up at the top, that prompt all the way up at the top. So I'm going to do pwd, and what am I looking at here? I'm looking at, oh, wild. So I'm looking at a / home, a / and then my username. The / are like backslashes in Windows if you're used to Windows. So what we're saying is, from the root of the file system, there is a folder called home, and inside that folder, there's another folder called your username, right? There's a folder named after your user. Yep, this is the absolute path, going all the way from the root of the file system, the root being all the way up at the top at that /. And so you're in this home folder, and to confirm that you're in the right home folder, obviously it shows that we have this username at, and this is the lab machine's name, but we can also type who am I, and that's going to tell us which user we're currently logged in as. And by the way, who am I works in Windows as well. And that tells me that I am in fact that user. All right, so our first two commands didn't take any extra options, right? Didn't take any extra arguments. We just said the verb, right? It's like go, run, sit, like single word sentences. But if we want to get a little bit more interesting, we have to run commands with options. So the first one I'm going to do is ls, which is list short. ls tells us what's in the contents of the current directory if we don't give it any arguments. So go ahead and press enter, and you're not going to see anything because your home folder doesn't have anything in it yet. You haven't made it. Now you might think, wait a minute, even when I start up a computer, when I have a brand new machine, if it's a Windows machine or a Mac machine, I'll have like a desktop folder, I'll have a documents folder. What's all that about? If we had installed Ubuntu Desktop, all of that stuff would be there. But because we installed Ubuntu Server, we don't mess around with that stuff. We only have the folders that we absolutely need. Giovanni, good to see you. So because we don't have anything inside of our home folder, we'd have to look someplace else to see anything interesting. So there are some places we can look, some places we can't. Let's go ahead and try to look at the root of the file system, right? That absolute top of this tree here. And to do that, we're going to do ls and then a single /. I can't stress enough that spaces between parts of commands really matter. In the Linux command line or Unix-like command lines, white space makes so much difference. Sometimes in infuriating ways, as you'll find out later when we start doing some bash scripting. But for now, go ahead and press ls and / and see what you see. There's a lot to see here. This is as though you were looking at the top of the C drive in a Windows machine, or opening up Macintosh HD in Mac OS. Is it still called Macintosh HD, or have they changed that? It's been a while since I've actually looked at an unrenamed file system on Mac OS. Yeah, case sensitivity Angel is actually kind of a complicated issue in Linux. That's very funny because it's not a hard drive in most cases anymore, is it? Okay, but so we have all these different folders, and we're going to get into what all of these are or at least most of the important ones, but notice that one of them is home, right? And so if I do ls/home, I'll see just one entry, which is my home folder right there. Let's make some stuff, right? So we have more things to ls. The first thing we're going to do is we're going to make a new folder. And to do that, we use the command mkdir for make directory. Mkdir needs a second argument. It needs a name to make. And remember that it's actually not a name, it's a path. So if I were to give it a / and then the name, or even if I were to put slashes inside the name, Linux would start looking for folders named like this. So when you're making files and folder names on Linux, make sure that you avoid /. All right. So, and actually avoid spaces too. You can do it, but it's kind of a pain. I would avoid spaces in especially file names and folder names if you can. But you can have spaces in them. So we're going to make a dir, and the dir, we can call it just test if you want. And now if we ls, you'll see that we have this blue thing. Yours might be a different color, but this blue thing called test. Now, we don't know whether it's a file, whether it's a folder. We don't know what it is. And this is where we start giving more information to the ls command to get us more information when we ask for what's inside of a folder. So ls has a lot of different options, and you can look at options that a command has a couple of different ways. The first way, which is often faster, is trying to do --help. A lot of commands have a --help option, and this one does too. And it'll give you kind of a brief usage and all of the different options that you can provide to it, right? And it's a bit of a skill to learn how to read these usages, but broadly you're saying, okay, ls, and then any options, and then the file or folder that you're trying to list. And we have some other options that we can look for here, right? Anything that we can add to it. This is too much to go over right now, but just know that these are in here. But the one option that I really want to focus on is -l, which is use a long listing format. This is going to give us pretty much all the information about the contents of the directory that ls can give us. So if we do ls-l, a whole lot, let me clear the screen and do that again, ls-l, a whole lot more information shows up. It's a little bit too soon to go over all of what we're looking at here. That's going to come up a little bit later tonight. But this D at the very top of our permissions column it indicates that this is a directory. Also, by the way, so does the size of the file. 4KB is the size of a folder. That just is how it is. But the D is really what indicates that it's a directory. Giovanni asks, should we use camel case or kebab case or snake case? I guess it depends on what type of project we're working on. So yeah, for file system naming, there's kind of a mix of dashes and underscores that you'll see. Camel case doesn't show up that often. I'll tell you something that I do pretty often if I'm making like a new note or something like that is I will do like a timestamp. So like 2021-07-14 and then my-file-name. That's a convention that I've come up with that makes a lot of sense for me. So I've offset the timestamp with an underscore, that's special. And then my file name, I just separated things with dashes. But use whatever works for you. There are no hard and fast conventions when it comes to naming files and folders. All right, let's go ahead, now that we've LS'd and we've made a folder, let's make a file. You can actually make a file without anything in it with the touch command. Touch is pretty cool. And this also gives us the opportunity to look at the other way that you can learn about commands on a Linux system, which is the man pages or the manual pages that are built in to Linux. So pretty much every command has a man page, especially the stuff that comes out of the box. Installing new packages afterward may not have a manual page, but the commands that you have on a fresh install absolutely do. So if we type man and then touch, which is unfortunate as a command sequence goes, but if we ask for that, we're going to get this new window that shows up that gives us all this information, very similar to the help, about how to use that command. Footpicks, good to see you. Thanks for chuckling at that. Okay, we're not doing Man Man again. It's a great Philly band, and everyone should look up Man Man. But I'm not playing them on the stream. But touch in particular will essentially, what it does is it makes a file if it isn't there, or just confirms that a file exists. Pretty interesting. By default, that's what it does. If you give it the -C option, it won't create a file. And by the way, to get out of the man page here, you press Q to quit. And then we're back to our regular terminal. So let's go ahead and touch test/test file. So what are we doing? We're saying that we're going to make a file inside the test folder that we already created. And then we're going to make this new file. All right, so having done that, if we do ls here, I just still see the test folder. But if I do ls test and ask for the contents of that folder, by the way, you might have noticed that happened really, really quickly. Sorry about the beeps. But you might have noticed that I typed that pretty quickly. I do have the ability to autocomplete file and folder names in the shell with the tab key. So if I start typing something and there's really nothing else that would match it, I can just press tab and it'll autocomplete as far as it can without hitting something that is a duplicate, right? So you can use that to speed up your typing a little bit. But inside of the test directory is our test file. And if I do ls-l test, you see I get a lot more information. But again, notice that this is a file. It has 0 bytes. It doesn't have any size at all. But it also doesn't have that D. I'm just serving up softballs for you, folks. It doesn't have that D for indicating that it's a directory. So we know that it's a file. All right, we've done ls. All right, now we're going to go over this in a little bit more detail. Oh no, sorry, just kidding. All right, we're going to leave these two files alone. Well, we're not. We're going to delete them. So we've created, now we get to destroy. So to destroy files is the rm command. And I'm sure Angel or somebody else is going to comment on the danger of the rm command. But rm and a file name will delete a file. And when I say delete a file, I don't mean gentle put it in the recycle bin, put it in the trash can. I mean it's gone. I mean you can recover it with like autopsy or some forensics tools, but it's gone, right? It's not being gentle. Orbital, good to see you. So when we rm test/test file, it's lost time. Okay, there wasn't anything in there, so no big loss. But I want to point that out. Now, if I do rm test, it tells me that it's a directory. Footpicks got those Python emojis. You also have the you should have the term. And for that reason, we have another command for removing directories, which is rmdir. Just like mkdir, we have rmdir. And then we give it to test, and now it's gone. And I do ls, and our directory is empty. Now, if I wanted to, let me quickly recreate those, right? If I want to do mkdir test, and then touch test file, if I recreate those, and I wanted to blow everything away all at once, and this is where things start to get a little bit scary, rm does have, look at the help for rm, has the, I did a tmux command, but I don't have tmux running, a -r, and it uses both capital and lowercase for recursive, meaning it's going to delete the thing you give it and everything inside. So if I give rm dash, I do a capital R most of the time because other tools don't have lowercase and uppercase. If I do rm-r and the test folder, it doesn't ask me any questions. It just goes and does it. And that's why the rm command must be used with caution. Now, we don't have elevated privileges right now, but if we did, you could imagine doing something like rm-r, and there's also an F for force, so rm-rf, and then just give it the root of the file system. And that would absolutely, if you were as the root user, that would just blow away your entire file system. And what's funny is your operating system would still kind of run for a little bit because things are still in memory, but everything on your long-term storage is history. So you'll see this all the time in like really mean Stack Overflow posts, like, oh, this is how you solve your problems, rm-rf/. Don't do this. And this kind of thing is also why you would never run like base 64 encoded commands that you can't read, and just you don't run commands that you don't understand from the internet, okay? Because you can really shoot yourself in the foot. All right. Let's see, where are we going next? All right, so we've talked about looking at files presence and directories presence. Can you run commands as base 64? So kind of, yeah. So if I wanted to do, that's a little bit outside the scope, but yes, there's a way, FootPix, of you can encode a command as base 64 and then pipe it to base 64-D and then like pipe it to the shell interpreter. Yeah, exactly right. It's not that different from how you do it in PowerShell. We generally don't do that in Linux just because why? We don't have the same sorts of, character length limitations that you have in PowerShell, which is one of the reasons why you do encoded commands. Legitimately, not just for malware. Okay. So we've talked about looking at the presence of files and folders, but what about what's in them? We haven't talked about text editors or anything else like that, and we're going to get there. But before we do, one command that allows us to look at the contents of files is the cat command. And cat is, let's do man cat, which is a little bit better than man touch, but it prints out the contents of files. Now, one thing I should mention at this point, we'll talk about this in more detail in a second, but I should mention that, did we already talk about CD? No, Angel, that's coming up. Good call. Most files in Linux are plain text files, meaning that they're easy enough to read just as a human. They're not binaries. There are binaries, but a lot of the really important configuration files and files that you'll interact with frequently are in fact plain text files, which means that you can look at the contents of them with the cat command. For example, there is a very important file in the /etc, which we usually pronounce as etc directory, called passwd, P-A-S-S-W-D. This file contains the database of users on the system, all of the users, including system users, not just ones that have logins. And it used to be the case that this would be where the passwords are stored. That's also not true anymore. But we can cat /etc/passwd or passwd, and we will see all of the users on the system. Now, there's a lot of information to unpack here, but what I want to start with here is that we can use the cat command to get out of to print out the contents of plaintext files. And obviously there's my user right there. All right, so to Angel's point, let's talk a little bit about CD. So we're in this one folder, but we don't have to stay here. Just like in a real file browser, we can move up and down and go to different directories. So let's go ahead and make that tester again. And we'll ls, and we see that it's there. Now let's say I wanted to go inside of that folder. And in fact, let's touch test file, test/test file, so we get that file back in there. Tester. There we go. So let's say I wanted to go inside of tester. I would use the cd or change directory command, and then give it the tester as my destination. Notice that my prompt changed, right? It added something to it here. Now it indicates that I'm in a different folder. The $, or sorry, not the $, the tilde is kind of a shorthand for the user's home folder. So this is telling me, oh, I'm in my home folder, and then I'm inside of tester. But what's the other way, if I didn't have that prompt, what's the other way I could confirm that I'm in tester? Correct. PWD. I want to print the working directory, and it tells me now I'm not just in my home folder, I'm one level down inside of tester. All right, I've done my work and I want to get back up. I want to get back into my home folder. There are a couple of different ways to do it, but the most important way that I want to teach you requires us to ls-l again first to learn something about how directories are represented in Linux. I'm going to do ls-l. Sorry, ls-l, but we also need to do not just -l. Let's try ls-a. We have to talk a little bit about a for a second. What we get when we do ls-a are these extra things. They're blue, so they might be directories. And let's do ls-a n-l. So we get the long format. And by the way, when you have options like this, you can combine them with a single dash. So I can say ls-al. And it works exactly the same way. So in addition to this test file, which we knew was there, we have these two other entries, 2 dots and a single dot. And interestingly, they both appear to be directories. What's going on here? Well, the single dot and the double dot are how the Linux file system represents the current directory, the one you're in, and the parent directory, respectively. So if I were to do ls dot, it tells me that test file is in dot because dot is the current folder. In fact, the truth is that when I do ls without anything, the dot is kind of implied. Now, if I do ls dot dot, all of a sudden I'm seeing tester itself because I am now asking for the listing of one directory up. And I can chain them. So if I do ls dot dot slash dot dot, now I'm up 2 levels. And I'm actually asking for the contents of cd/home because I'm up 2 levels from where I am right now. Can I go all the way up? Sure can. And now I'm back at the root of the file system. By the way, this is something that security professionals will be looking for in terms of vulnerabilities, where this is called directory traversal, and in some contexts, you don't want users to be able to do it. And in this case, it's fine, but you could imagine that if a website was served on a Linux server and the way the directory structure was being interpreted allowed you to read, for example, etc password or some other sensitive file right from the web browser, that wouldn't be so good. Okay. Let's talk for a second. Let's get out of the... Let's cd, and we can also cd to specific targets, right? So I can do cd/etc, and you can see that I'm here in /etc. I can do also cd tilde to take me back to my home folder, or just actually cd. So if I go, oh, cd and a dash takes me back to my previous location. It's like the back button on your remote control. But if I do cd without anything, it actually takes me back to my home folder too. Okay. Let's take a break from the terminal and let's just touch on a couple of other things that I wanted to make mention of. Okay. Yeah. So before we move further, I want to say that one thing that you're going to get used to in Linux is that pretty much everything is a file. Everything is a file, including things like processes have running programs have file representations, and even devices that you connect to the machine. Network interfaces, storage devices, they all have file-like representations. And so getting really comfortable with looking at files in that way will be very, very helpful. The other point I wanted to call out before we go any further is kind of the backing philosophy behind the commands that we're using right now. And that's the Unix philosophy. So the first thing is that in the Unix philosophy is 3 parts. Part 1 is make small programs that do one thing very well, right? Do a thing and do it well. Don't try to do everything. That's part 1. Part 2 is make programs that work well together, right? So there should be good interoperability between those very well-designed single-purpose applications. And how are they going to work together? The decision at the time of the Unix operating system, back in the late 60s, was that text was going to be the universal input-output format. Now that might sound like no big deal, but it really does matter, because then a lot of what you're doing in Linux is about parsing text and reshaping text, human-readable text. And I think today that distinction matters even more because another command line interface that we use constantly as IT professionals doesn't share that philosophy. So PowerShell does not work on a text-based interface. PowerShell is designed around data structures and objects. Can you get text out of it? Absolutely. But it's actually not designed around raw text. It's designed around data structures in code that can be manipulated a little bit more like a programmer would. So that difference really matters. Right. So as I said, everything is a file. And when we create configurations or we change configurations in our Linux server, what we're doing a lot of the time is we're messing with text files. All right, so let's jump back into the terminal just for a second, and let's get that ls-al, and we'll do a / for just the root of the file system so we can see all of the root file system folders. Bin, boot, dev, etc, home. There's a bunch of them. And it can be a little confusing what's where and what anything is, what these things are for at first. And to help out, I put together just a little bit of a quick diagram here. So here are some purposes for these folders. The /bin folder, these are the core binaries, right? These are the things that make up the basic operation of the Linux system. And as a matter of fact, to demonstrate the kinds of things that are in there, let me show you something. There's another cool command called which, and which will tell you the location of the commands that you're running, because all of the commands that we've run so far have a location. They're programmed somewhere on the Linux file system. So if I do which ls, for example, it tells me that it's in user bin ls. If I do which cat, right, it's at user bin cat. If I do cd, it's not anywhere actually. About cp for copy, it's in user bin. So most of the stuff that we do, we work with most of the time on the shell is going to be in /user bin. But we can look at things in ls/bin. There's going to be a lot here, right? A lot of things, some of which we're going to talk about, but these are the kinds of things that the system has to worry about. Touch might be in here actually. Nope, user bin. But find, which we'll talk about a little bit later, is definitely in there. So back to our chart. /bin, core binaries necessary for the system. /sbin, these are system binaries that the OS is going to work with, you less so. /etc, that's where configuration files tend to go, especially for running services on a machine. /var, really, really important folder. This is where files that change frequently are going to live. Importantly, logs. So logs from different applications and the system log will live in /var. /opt, not a lot going on out of the box in /opt. It's a folder used for optional files. So a lot of times administrators will install additional services or programs to /opt. And by the way, for the security folks around, if you're red team and you're enumerating a Linux system, don't sleep on /opt. There is often really, really spicy stuff in there. /dev is a pretty crazy directory. This is where device file representations are going to live. So everything from the monitor that you're using to the terminal that you're typing into, all of these have file representations in /dev. /home, we've seen, is where the user directories live. /usr, user binaries and read-only data. We saw some of those already. Now /boot is a little special. This is where files that have to do with the startup of the Linux operating system actually reside. So it's actually kind of loaded, often it's on a separate partition, but /boot is kind of the thing that gets loaded first before the rest of the OS. /root is the user folder for the root user, which we haven't talked about yet, but is kind of the super user, the administrator of a Linux file, of a Linux computer. /tmp is temporary files, might be empty, might not be. And /proc is the process file representations. So just like devices have file representations, processes running programs will also have file representations. Okay, I know that was a lot. There was a lot of info dump. That's why we record these, right? So you don't have to necessarily memorize these. And actually, I want to make that point. If you're learning this stuff for the first time, let's remember that it is not the expectation, even of seasoned administrators, that you have all of this memorized. Instead, we rely on what's called transactional memory. And so it's not that you know what it is, you know where to go find it if you can't remember. That's the more important thing to remember, is how to discover it. And then the stuff that you need to remember is the stuff that you'll be practicing all the time anyway. All right. Now we're going to get into a pretty important topic, which is about files and permissions. who can see what and how do we change it on a Linux file system. Let's get back over into our terminal and play with this a little bit. So the first thing to understand about files and permissions, we actually need to know a little bit about users. It's interrelated. Now, we saw when we catted etc password a whole bunch of information about all the users on the system. And in fact, we saw up at the top of that list was the root user. And the root user is important in a Linux computer because it has unlimited ability to make changes and to view all files and folders, all processes on the system. Okay? All users on a Linux computer have a user ID, and the root user is always ID 0. We have an ID too. Mine is 1000. Yours might be a little bit different. You can find out what yours is at any time with the ID command. And that'll also tell you a little bit more information about your user account, not just your user ID, but your group ID, which we'll talk about in a second, and then groups that you are in. So the ID command, pretty important to understand who you are and what you can do. Let's see. Good, tester is still there. So let's do ls-al again on our home directory and take a look at some more of this information from ls and understand what it is we're seeing. You see there are several columns here of information, right? This column here is our file size. These columns of text right here are modification dates or creation dates. And right here, these two columns over here with our names seemingly repeated are the owner of the file and the group of the file. So files belong to both a group and a specific owner. And that's the way that we think about permissions on a Linux file system. What can the owner do? What can the group do? And what can everybody else do? And that is defined in 3 different permissions, broadly speaking. Reading a file, writing to a file, manipulating it, and executing a file. So if it's an executable file, can we run it? Read, write, execute. R, W, X. Those permissions are how we define everything on a Linux file system. So to recap, let me just bring up a text editor very quickly just so we have a visual aid here to talk about that. Right? So every user, right, or every file has an owner, a group, and then everyone else. Although very often we use different letters to represent these. We'll say the user that it belongs to, the group that it belongs to, and then O for others, right? So you go. Now, everybody could potentially read, write, or execute. Read, write, execute. Read, write, execute. And that's very similar to what we saw in those permissions, right? If we put these all together, I can't scroll up to see it, but it looks very much like what we were just looking at. See? RWX, R-X, meaning that permission is missing for this, and then here. So if we look at my tester, right, the owner is me. That's the first 3. So I can read, write, and execute in here, no problem. The next is the group. That's also me. So I can still read, write, and execute. And then everybody else can read, not write, and execute stuff inside in this folder, or can execute this folder, which isn't a thing. But then inside of it, if I do ls-al tester and like a look inside of it, right? You'll see that the permissions kind of are very similar. The only difference is that the execute bit is not set, the execute permission is not set because this is not an executable file, right? Whereas directories have it so that things can inherit it. That's not a problem for this file that isn't executable. So again, I, the owner, can read and write to it. The group is still me, so I can read and write to it. And then everybody else can just read it. But what if I didn't want other people to be able to read my stuff? What if there are other users on this system and I don't want them to be able to read my stuff? I have to be able to change the permissions of this file. Well, how do I do that? First of all, let's get into testdir just so that we can work very easily with it. There is a command called the chmod command, or change mode, the permissions mode. And there are a couple of different ways that you can use chmod. The first way is the simple syntax, which I'm gonna show you first, which we can use to add permissions to a file or a folder or take them away. So if I wanted to remove the read permission from test file, I could do chmod -r and then test file. Let's go ahead and try that. And then let's do ls-al again to see what happened to test file. Oh snap, look at that. So the read permission has disappeared, but unfortunately it's disappeared for all three constituencies, right? It's disappeared for the owner, which is me, the group, still me, and everybody else. Now, I wanted that to happen. I wanted everyone else to not be able to read it, but I still want to be able to. So I have to be a little bit more precise with my simple syntax. And so let's go ahead and fix that a little bit. If I do chmod +r, test file, right, everything's back to the way it was. Okay, but I still need to get that R off of this section. How do I do that? If I do chmod O for O for others -r, Tacos, thank you so much for the follow. O-r test file. If we do this again, now this is exactly what I wanted. And because I specified that it was others that I wanted to remove the permission from, now I was able to remove the ability from anybody else from reading this file. Okay. And of course, I could do, if I wanted to add execute privileges, this isn't an executable file, but if I wanted to add execute, I could do chmod, let's say I want the owner to be able to do it, or the user. It would be u + x test file. Now it's green because it's an executable, but you also see that I have that X set there. Okay. There is another way of using chmod that I prefer because it feels a little more precise to me. And I feel like it's worth taking a moment to go over it now, just so we have it there. And let me pause for a second. We've been at this for about an hour. If you're feeling like your head is full, that's okay, right? Take a break or keep listening, but if you're feeling like you can't absorb it, just like recognize that and understand that you can go back and watch these again. The brain only has so much acetylcholine in it at any given time, right? And it's essentially the chemical that allows synaptic connections to happen and strengthen. It's what allows memories to be made. And it's a finite resource, right? It can be replenished, but if you're doing a lot of heavy learning, you will deplete it. And so if you've ever been paying attention for something for a while and you're just like, I'm done, that could be what's going on. So I just want to mention that it's okay to feel like we've covered a lot already. So if you're feeling that way, just recognize that. It's okay to go back and have to review it later. There's no expectation here that you're going to watch all this and just like get it. Okay, I'm putting the information out there so that in case anybody has questions, we can have that conversation, but it's absolutely intended that you can review this stuff as necessary. All right, so we're going to talk about this other chmod method. And to do this, I'm going to have to bring up my handy dandy text editor here. And again, we're going to go ugo for users, groups, and others. Now, we talked about how we have RWX, RWX, and RWX, read, write, and execute. These are the possible permissions. Well, what if we represented each of these, because they're switches, right, on and off, what if we represented each of these with a 0 or a 1, right? So 0, or let's say it's read, write, read, write, read, write for everybody, right? So 1, 1, 0, 1, 1, 0, and then 1, 1, 0. Read, write for everybody. Well, we can describe those numbers in decimal. If they're binary, we can describe them in decimal. And so remember that. Let's take let's break one of those down, right? The 110 that we have. If this is binary, and we're talking about place value, right? This is the ones column. This is the twos column. And this is the fours column, right? If you think back to your elementary school math, your place value, right? So I have one group of 4 plus one group of 2 plus no ones. That's a 5. Oh, sorry, that's wrong. One group of 2, I had a 6. I was like, that doesn't seem right. Okay. I was an English major. And I can do that for each of these 3 sections. And so what I end up with is the ability to describe the permissions for a file or a folder with 3 digits, right? So here it would be 666. But let's say I wanted to add the execute bit, right? Here and here. And I actually wanted to allow everybody to execute, but not write. So now I have, that's 7, right? 4 plus 2 plus 1, and 7 again. And then for my everybody else, that's 4 plus 1, which is 5. And I can use those sequences of digits to describe permissions on my files. Let's give it a try. So here's my test file. I want to change it back so that the owner can read, write, and execute, do everything. And the group and everybody else can only read and execute. So owner can do everything. Group and everybody else can only read and execute. I'm going to give you a second. Chat, what do you think the permissions in that form would look like? Wait, what's the question? Classic. Have I taught you before? The question was, what would the permissions be for a file that in that mode, which is actually octal, but what's the permission set for a file where the owner can read, write, and execute, and the group and everybody else can only read and execute? Orbital has it, 755. So if we do chmod 755 and test file, We got it, right? So we have RWX for read, write, and execute, and then read and execute for the group and everybody else. Do you see how that's like, once you understand how to put these together and think of these as flipping switches and then just converting them, I find that a lot faster than the like U plus X syntax, but both are acceptable. Okay, Lil Didi, tell me a little bit more about where you got lost. See if we can fix that. Husky, thank you for the follow. Yeah, that was surprising too. So just to recap, we have chmod, or change mode, which allows us to change the permissions on these files. Orbital just flipping the subs. If you would want everyone to read, write, and execute, it'd be chmod 777. That's exactly right. You got it. And why is it sevens? Why is it sevens? Where's that 7 coming from? The additions of what? Be specific. If we think of a user, group, or everybody else's permissions as zeros or ones, right, on or off, and we put them together, right, we have like a ones column, a twos column, and a fours column. Exactly right. You got it. You got it. Yep. And we put them all together, and then we combine them in sequence to make those 3 numbers, right? So this is owner permissions, this is, the second one is group, and then it's everybody else. You got it. Okay. While we're here, we also have to talk about another cool trick that you can do with files in Linux. Actually, you can do it in Windows too, but hidden files. So we know that when we just did an ls-l, we only saw a test file, right? But if we did ls-a, we saw the dots, and ls-al, we saw the dots, which represent the parent folder and the current folder, right? But dots on a Linux system are also, if you have a file name that begins with a dot, going to hide the file. In fact, let's go back up to our home directory with that cd ... and do an ls-al. Or let's do ls. Does it get bigger than 7? Not in this case, Didi, because we only have the 3 permissions, right? Read, write, and execute. And what that means is that there are only 3 columns in the binary digit, right? 3 place values in the binary digit. Right? If we went up to 8, we would need a 4th column. But, yep, nope, no bigger than 7. Okay, so if we do an ls, there's just the tester in there. But if we do ls-a, and I'll do an L just so it's lengthwise, there's a whole bunch of other stuff in here that we couldn't see before. What the hell is this? These are user files, right? Like .viminfo, which I just made by using Vim. But these are parts of the user folder that are there just as a function of using the shell. They'll be produced for you. And they are hidden from view because they are prepended with that dot. And sure enough, you could do the same thing. If I do touch dot can't see me, and I do an ls, it's not there. But if I do an ls-al or -a, it's there. It's there. So I just want to point that out, that there are ways to create hidden files. They're not super hidden. They're just really hidden for convenience. They're not meant to be secrets. Okay. Can letters ever be capital? Sure. God, Mr. Taggart. Haven't been called that in a couple years. And in fact, let's see what happens with case sensitivity. Right? See how I can have a lowercase and uppercase? Oh. Can you have DRW? Sorry, I misunderstood the question, Gromit. No, these will only ever show up in lowercase because that's just the way that the permission structure works. They're defined with lowercase letters. Now, there are some other letters that you'll see in there, but we haven't gotten to that just yet. All right. Any other questions on file permissions and users just yet? Yep. TNS. So when you create something with touch and the dot in front of it, why is it hidden? Because there's a dot in front of it. The shell is designed specifically to omit files that have dots at the beginning of their file name. That's it. Footbix keeps throwing paper airplanes at me. Well, are they good? I see the chat, like, failed. Let me see if I can reset that. Oh, nice. Well, I don't know. Make your own. Do better. I don't know what to tell you. Yeah. Streamlabs is being a butthead. If I... With the chat, if I turn it off and turn it back on, does it, like, reset it? No. Okay, I'm gonna try something. Alright. Somebody say something. We'll see if it shows up. Nope. Okay. Well, that's disappointing. Good job, Streamlabs. I thought I remember there was a way to reset it, but oh well. All right. Let's get back into the slides real quick. I did. I deleted and re-added the source. So some quick recap on some of the stuff that we just were talking about. DD, no. If you create a text.txt, that would not be hidden because the dot is at the beginning. Or sorry, the dot is not at the beginning of the file, right? It has to be at the beginning of the file. If you created a dot text.txt, then it would be hidden. So yep, just some recap here that users have a unique ID. They're recorded in Etsy password, not password. Note that. Passwords are commonly stored in Etsy shadow, which you can't see as a regular user. Only the root user can see this file. We haven't talked about how to become root yet, but we're about to. So the highest amount of privileges is reserved for root, and it should not be used as a logon user, but we can access it via the, depending on how much of a neckbeard you are, you'll either pronounce it as sudo or sudo. It is actually supposed to be sudo, and now that I know that, I can't like not. Because it's supposed to be super user do. It's not like sudo, like, you know, pseudopod or pseudoscience. Although that's the way I said it for most of my life. And then I took the Linux Foundation certified sysadmin course and I got ruined. Sudoku. I'm so annoyed by the chat thing. I don't like putting up a stream that doesn't have the oh well, it is what it is. Okay. Let's demonstrate how to let's see. Talked about permissions. There are a couple of other commands for chown and chgroup are for changing owner and for changing group, and that allows you to give a different user. You can give it by username or group name to change the owner or group of files. And we talked about our chmod syntax. Yep, all good. And by the way, I will make these slides available for folks. I'll put those in the Discord so that everybody can review them. Okay? All right, we did our permissions by example. All right. Now we're going to start using some fun output stuff. Ooh. Well, refresh Streamlabs. Okay. Thanks, Angel. Some of that stuff seems like it's going to require me to stop the stream, which is not going to happen. But I appreciate the link, sir. Okay. Let's talk about using output. Oh my god, it is. Yeah, I pressed the refresh chat button. I don't know. Angel, I think you just scared it. Okay. Need to do with sudo. I love it. So actually, yeah, let's talk about sudo really quickly. So sudo, or sudo, allows us to become root in a couple of different ways. Now, su by itself is just switch user. There are no other users on this system. We'll get there when we start doing challenges. But su is for switching user, right? Su other user, and then you'll have to enter that user's password. But for sudo, let's do a -help. There are a lot of different options here, but the two that most people use to become root are sudo-s for shell or sudo-i. And I tend to use sudo-i because it's what we call true root, right? It becomes the root user without any of the holdover stuff from the original user. So if I do, let's do that. If I do sudo-i and I enter my password, presuming I'm allowed to do this on the system, I know that I am, and your user, if you set up the lab, is as well. Now I am root, not Groot. I am root. And if I do pwd, you'll see that my home folder is different. It's in that /root. And now I have a lot of opportunities to mess myself up. So I want to be very careful when I'm the root user. Very rarely should I run a shell as root, unless I'm running like a try hack me or hack the box that I'm trying to get there. But in normal Linux operations, I don't want to be using the root user for pretty much anything. And the reason is, if we look at ls-al like /bin, it owns everything, right? So I can really do a lot of damage there. I want to limit the permissions of the users that I employ, both on the Linux file system and in an organization. All right. Now, we talked about cat, right? Let's also play with the other way, right? How do we get file into? Ooh, getting a little punchy. How do we get text or content into a file? We know how to get it out. How do we get it in? Well, one of the ways is via what's called output redirection. Now, obviously, we can use text editors and things like that, but text editors are next week. So before we have a text editor on the terminal, we're going to play with some other stuff. One of the commands that is really easy enough to use, you don't use it that often just on the command line, you'd use it in scripts, is the echo command. And it's like the print command, right? So I'm going to do echo hello world. I get hello world, right? And what's going on is the echo command is generating output, and that output is being sent to what we call the standard output of the system. Whatever the standard output is defined as. In this case, it's being redirected to the terminal that we're using. But that's not the only place that we can send output. We can send, because by the way, that terminal is a file. We said that everything on Linux is a file, so our terminal has a file description. If that's true, we can send that output to someplace else, like our own file. So we're going to rerun that echo hello world command. By the way, you can get old commands up with just like an up arrow key. And this time I'm going to redirect it to a file. In this case, I'm going to use the greater than sign, or the left alligator if you're in 5th grade, and send it to hw.txt. Nothing shows up on my prompt, on my terminal. But now I have this file, hw.txt, and if I cat it out, the contents of that echo are then inside that file. So really, really, really useful if I want to capture information. What if I want both to happen? What if I want to see the output, but I also want it to be saved to a file? Well, there's a command for that called the T command. And think of the T command as like a T-junction in a pipe, where, yes, there's going to be flow this way, but we're also going to redirect some flow this way. So for this one, we're going to do echo hello T. And this is where we have to learn about the pipe. We just learned about output redirection, right? So we output to a file instead of to the standard out. We can also, and this is really where the Unix philosophy comes into play, we can pipe the output of commands to other commands as their input. So there is a rev command. Notice that pipe. This is the key, by the way, above your enter key. right? The backslash, but hold shift. The rev command just reverses input. Oh, so it is. Thanks, Angel. I would have thought that was a blessing, but if you really want to see my face in more focus, you're welcome. But yeah, so the rev command will reverse any input. So we gave it the input from the echo, but we used the pipe command to get it there. And we can chain these, right? If I do rev again, it becomes the original. Now, I said I wanted to use the T command to see output and then save it to a file. So I'm going to use T, and then we'll say t.txt. So what's going to happen is I'll see the output, but also a file called t.txt will be generated that has that output. That's really, really handy, especially if I'm doing like a test of something, if I'm doing a ping test or some other kind of network thing, and I want to see the output, but I also want to save the results. T is crazy handy just so I can capture that information. And that pipe command is what's making it work. I love tea. I have a bunch of Irish breakfast in the cupboard right now. Berries. Also, Bigelow vanilla chai. It's like candy. Incredible. Now, in addition to the single bracket, there's actually something else we can do. So the problem with the output redirection is that by default, it's going to overwrite anything that's already in the file. So if I do echo hello you to hw.txt and cat hw.txt, that hello world that was there before is gone. So if I want to append to a file, I can do that with two brackets. And this is the command to append my output to the file that I'm targeting. So now if I cat hw.txt, I have two lines. Again, very, very handy if I'm kind of generating stuff in sequence and I want to append it to a list. I'll be able to do that with the two brackets for output redirection. Okay. We're coming close to the end of the info dump stuff for tonight. And then next week is going to be a lot more interactive. But there are a couple more commands that you have to know in order for the challenges to make sense. And these are some of my favorites. So the first one is going to be the find command. Often misunderstood, very, very, very powerful. The find command allows us to look across the entire file system for files that match certain patterns. So if I do find has a kind of unique syntax though. So I want to make sure everyone pays attention on this one. So find, the first argument to find is where find is supposed to start looking. Okay? So if I do find and the root file system like this, it's going to look across the entire machine. If I do find and dot, then I'm going to start looking in my current folder. And I can give it anywhere in between, right? Now, I may not have permission to look there, and we'll talk about how to deal with that in a second. Now, let's say I'm going to look for anything with the file name test and anything like it. Well, to do that, I'm going to give it the single dash and name. It's a weird command in that it doesn't meet the same pattern that I told you about before, where options are a single dash and a letter or two dashes and a whole word. In this case, the option is a single dash and then the word, and that's because it has kind of a different pedigree. It comes from a different family of programs. But anyway, find where you're going to start looking, and it's going to recurse down from there. Dash name, and then we'll give it test and asterisk as kind of the wild card, so like test dir, things like that, right? Or we could give it star.txt. Oh, sorry. Put that in quotes. Double quotes or single quotes, that'll work. And now, notice that I'm getting my 2 files here. Now that's cool. Let's see what happens if I look across the entire file system. Make that a root. This is going to get crazy for a second. Now, if I want to stop this from running, press Control-C. That breaks the process. There's a lot that we just saw. And there are some places that I don't have permission to read. So one thing that I'll often do when I am doing a find across the entire file system is I will do an output redirection, but not of the standard output. There's another channel of output for errors. And to output that, it has a different numbered file descriptor, it's called. So if I just want to change that output, I can use that number before my output redirector. The standard error is output number 2, or file descriptor number 2. And then if I want to just get rid of all errors, I don't want to see them, I don't want to save them, I'm going to send them to /dev/null. This is kind of a next level trick, but I think it's cool to see. What this does is say, okay, any errors, send them into the incinerator, basically. Dev null is basically a black hole where it's not a real place, right? It doesn't actually store any data. And so you send it there and it's gone, which means it'll just omit those errors. That's really what we're doing. Right, so it's still a lot because I'm looking for every text file in the system, but I'm never going to see an error because I'm sending my error output, which is output number 2. Standard in is file descriptor 0. Standard out is file descriptor 1, and standard error is file descriptor 2. Okay. So that's fine. One other thing, send it to a file so I can show the error message. Yeah, let's do that. Good call, Angel. So see, when that was fast. Let me show that again. So when I redirected the errors to a file called errors.txt, and now I cat out errors.txt, I'm getting a whole bunch of permission denieds, right? And I don't want to see those when I'm running the list. So that's why we do the redirect to dev null. One other thing that you can do with find that I think is pretty neat is you can run commands on the things that you find. So with that, we can do a -exec. And then this is a little bit tricky. Actually, yeah, let's bring it up there. -exec, and then what you can do is say cat, if we want to cat out the file, and then 2 curly braces, which represents the file that we've discovered. And let me change this to the local folder, so I'm just catting out the text files that we have. And this part gets a little bit weird. I have to do a semicolon and a backslash. Nope, other way. Backslash and a semicolon, which is the way that you tell the exec command that the command you're supposed to run, or the exec option, that the command you're supposed to run is finished. So basically, once you put in cat and the placeholder, you always need a backslash and semicolon to say, that's it, that's the whole command. Once you do that, for everything that find finds, it will run that command. Now, that's a lot of text because of the errors. If I just do ls dash, let's do ls-l. Right now, it's running all of those for me. but it's running ls-l for each one of those. Now they're all in this folder, but what if they weren't? This could be really helpful to learn more about the files across the file system that I had discovered. Or just add the ls argument. Yep, for that particular one, you could definitely do that. All right, last one. Second to last one. So that's how we look for files across the system. But what if we wanted to look for content of files? Or what if we wanted to filter content of files? For that, we have the grep command. Grep is super important. By the way, does anybody who has some familiarity here know what grep stands for? Grep is the GNU regular expression parser. And because GNU regular expression parser anymore. So there's some fight about what the G is actually. John Doe, you're not wrong. When Richie wrote it wasn't GNU, but the one that comes packaged with Linux is a GNU component, so now it's the GNU regular expression parser. But you're not wrong. It was the general regular expression parser when it was written. Okay, so what grep does is it allows us to look for patterns in a file and find lines that match it. That's its default function. So for example, if I do grep u in hw.txt, right, it found a line that has the word u in it, and it highlighted it for me. That's real handy. I can also, for much larger things, if I do grep taggart in /etc password, right, I'm going to just get the line that has my username in it. Right, in this case, my full name. So I can cut through very large files quickly with grep. Very, very, very handy. Now, grep by default can take, just regular text, but you can also flip it. You can say grep-v to say, okay, find everything that doesn't match this. And so what that'll give me is all the output that doesn't match, right? So my username is actually absent from this list. I can also tell it to search case insensitive. And notice that when I did that with the I, not only did it highlight my name here, but it highlighted the matching username when it occurred. Grep is so powerful and it's so fast. As a matter of fact, grep can even go inside of folders and look for contents within folders with the grep-r option. So it'll look for content across multiple files inside of folders that way. Okay. The last command that I wanted to talk to you about is something that is near and dear to the security people's hearts. You can always throw in color equals auto or color equals always to make it easier to see if your Linux host doesn't highlight it by default. Great tip, Husky. Great tip. Okay. So the last thing that I want to talk about, and really this is just because you need it for the challenges, is we're going to talk about file hashing. This is something that we use in security all the time, but it's also something that people use to demonstrate file integrity. So we have these mathematical algorithms called hashing algorithms. And what they do is they are one way mathematical algorithms that generate a fixed length, unique string from a given input. And they are, if the math is good, they are unique, right? And they are also wildly different, even if only a little bit of input is changed. Because of these properties of hashing algorithms, we use them for forensic integrity. So like when we take an image of a disk drive, we make a hash of it. So we guarantee that what we caught is what we present as evidence in forensics. But we also use it to demonstrate file integrity, even if we're downloading something or proving that we've actually downloaded the file that we want. And some of these hashing tools are built right into Linux. So one of them is MD5, and there's a command called MD5sum. And if we give MD5sum one of these files, right, hw.txt, for example, it'll give us the hash, the MD5, which you shouldn't use in real life, but it's short and easy right now. The MD5 hash of this file. And by the way, echo, I'm just gonna a single character to the end of hw.text, and we'll run that again. Notice it's completely different. That's an important property of hashing algorithms. Small change in the input, absolute change in the output. What am I doing with echo-n? Oh. But does changing the file name change the hash? No, it does not. Good question, Husky. Now let's talk about renaming, right? So MV is for move or rename. Can't believe I blanked on that. We should also talk about copying. So let's first do that. Let's cp hw.txt to hw2.txt. So cp is for copy. And if we wanted to copy folders, it would be cp-r for recursive. And then mv is move or rename, hw.txt. The reason mv is name, it's move, is because it's the same thing. A move and a rename are the same on a Linux file system, right? So if I move it, I can send it to like temp hw.txt, or I can just move it to hw1.txt, right? And yes, if I want, so Angel, to your point about the if I do echo-n, right, without the new line, that'll be the text content. But if I want the full file, right, this is what, including the line break, because that byte is in there, I want that. But yeah, if I did echo-n, oh, one character. Good point. Good point. It wasn't one character. It was 3. Or at least 3 bytes. Echo-n test MD5sum. I can pipe that there, and it'll give me notice that if I do the text piping to MD5sum like this, notice that the hash is different depending on whether I use the -n or not. And basically that's saying, am I including the new line? Really good call out. All right. So MD5sum, there's also SHA-256sum. Which is much longer. It's also more, it's not broken. MD5 is actually a collided algorithm, but it's still used in some circles. Okay, so we've got some hashing algorithms. It's important for our challenges. Now, let's talk for a minute about the challenges. We can finally set those up. We're not there yet. Okay, so to set up your challenges on your lab machine, the first thing you're going to need to do is go to... I have to open up a browser window. You're going to go to github.com/mttaggart/hs21 files. And this is also linked inside the syllabus, but I'll put the link here in chat. And what you're going to do is just go ahead and copy that URL. And a word on these challenges. If you look inside the folders, can you find some answers to the quizzes? Yes. Should you? That's really on you. I made some of this stuff secret, but some of this stuff, yes, you're going to be able to look in the back of the book for answers. That's up to you. If you want to challenge yourself, don't look. If you want to cheat, that's okay. Okay, so once you have that URL, and I would recommend doing this from the home folder of your admin user, right? The user that you set up for the lab VM. You're going to go git clone and that URL. Once it pulls down all that information, you'll have this new HS21 files folder set up inside of your home folder. Go ahead and cd into it with HS21 and just tab you get in there. Okay. From there, and this part's important, you're going to run sudo /setup.sh and enter your sudo password. Okay, it's going to download a bunch of stuff because of the way this thing works. So it might take a minute for it to download everything and install. So any questions of anything about anything we covered today while this thing is installing? I know we covered a lot. So again, let me recommend that anybody who's interested in, following up, join us on the Discord. Especially throughout this period, but really anytime. I'm trying to make myself as available as I can to answer questions. And of course, I'm not the only one in there. This entire community of learners will be able to help you out. We have some absolute rock stars here. I'm not sure what you're referring to, Angel, but okay. Some background. To make this work, I basically had to write my own quiz engine because I couldn't find anything that worked the way that I wanted to. And the quiz engine is written in Rust. Which I'll show you actually. So yeah, took a while to get all this working the way that I wanted. But And the reason I had to do it in a systems programming language, I started it in Python. The reason I couldn't do it in Python is because there's a lot of stuff that I needed to set the UID bit on for security. But you can't do that with scripted binaries. They have to be compiled. Not the way that I wanted. I want to let this thing run and do the install because I want to walk everybody through it. But while this is going, let me talk a little bit about what we're doing next time. So next week, we are going to do a deep dive into the Vim text editor. So we often have a need to edit text even on a server, right? Even if it's not a desktop. And Vim, there are lots of other options, right? There's other text editors. Some of them are a little bit easier to use. But I think it's worth learning how to use Vim because it's this text Swiss Army knife. It's really, really, really powerful. It's so important that I made an emote for it. And I can tell you really without any exaggeration that in my day job as a cybersecurity analyst, I use Vim almost more than any other tool, right? Other than like the enterprise stuff. And we'll even go over how to customize Vim to make it a little bit friendlier. Because there are some things you can do to make it a little bit more fun to work with. So don't miss that one. All of you nano people. Okay, let me just ask. Let me just ask. Because I don't remember anymore. I'm too far gone. What is it when you encounter Vim? What is it that messes with you the most? Or what is it that keeps you away from using it? It's good. I don't know how to use Vim. But have you ever opened it up and what has the experience been like? Other than not knowing how to exit. Okay. I think it does mess with people that there are different modes, right? It's just not like open, not open and type, right? That's confusing. But once you get past that, I think it's pretty cool. Oh, pasting is interesting. Pasting is interesting. Yeah, the Vim that comes even with Ubuntu Desktop by default doesn't have clipboard set up the right way. Neon, you're absolutely right. The way emotes work is unintuitive if you use any other text editor. It's a pretty unique concept. So for any of you who have never seen this happen, no. No WQ. X. All right, finally this thing is setting up. So you're going to see a couple of... Ooh. I may have to fix the... Do like a quick patch. This shouldn't be happening. No. Yeah. For net 1. That's okay, I'll fix that. So, luckily the setup is idempotent, so if you have to rerun it again, it's fine. So I may push a fix to that. But otherwise, this is how you begin the challenge. Log in to start. The user starts 0 with the password HS21, and let's begin. And all the flags look like this. But all of your flags are unique because they have been all of your flags are unique because they used my passphrase generating API to create the flags. So everybody's flags are different. That was just like a cool trick I wanted to do. So if we SU to start 0, I mean, you can cheat, but not by just guessing flags. So if I SU start 0 and then paste in or type HS21, let's begin. Now I'm user start 0. And let me CD to get into start 0's home directory. And if I run quiz, I really hope this works. Yep. This is how how quizzes work. Enter HackSummer for your answer. And then you'll get the next user and the next password. That's how the challenges work. So we haven't covered all the material, right, for all of the challenges, but through all the command stuff, you should be able to. Yep, this is very much like over the wire. That was how I modeled it. Right. So you might want to hold off for a second while I fix that bug that I saw. But I'll put that up in the Discord when the net stuff is fixed. I don't know, that was annoying. But other than that, I think we're good to go for tonight. So that'll do it for this episode of HackSummer. Thanks everybody for hanging out. Of course, next week is Vim, as we've been talking about. And I'll just once more shout out the Discord. And I don't love doing this.
Thanks.
Thank you, Orbital. But this stuff does take some time and effort. So if you don't feel like subbing and you want to say thank you another way, I do have a coffee page. And so if you want to give a quick thanks there.